The mathematical sequence to determine RT, I'm using the same strategy that I did for series circuit to derive a equivalent resistance for that type of circuit. I'm going to use the same approach. So I'm going to start with equation 2, which states that the total current is the sum of each current that flow through each light bulb, in this case I1 plus I2. Then I'm going to use Ohm's law for current, which is voltage over resistance. Now I'm going to substitute the value of current in terms of voltage and resistance on equation 2. Now I'm going to have a different type of layout here. So my IT will be VT over RT. My I1 will be V1 over R1. And my I2 will be V2 over R2. Now, since we state that all the voltage in a parallel circuit is the same, instead of label differently, I'm just gonna call plain V. Now I'm going to substitute the voltage that is labeled as VT as V, V1 as V, and V2 as V. Now let me rearrange in terms of V. Now, my first term of this equation remains the same, but the second one I can factor it because V is a common term for the sum. So V here will be V times, all right, between brackets, 1 over R1 plus 1 over R2. Notice that if you multiply V times 1 over R1, you go back how it was before because now I'm using the reverse of factoration, which is distribution. Is another term for math. Now what I'm going to do is I'm going to divide both terms by V because I want to get rid of V and leave my equation just in terms of R. So when I do that, and then I cancel V with V, and now I have just 1 over RT. And on the second term of this equation, I'm going to cancel V, and now I will have just 1 over R1 plus 1 over R2. This is my equation 3.